Hello students, today we will be doing the unit number 3, magnetism, and in magnetism the first chapter is magnetic effect of current. Okay, what are the important points? Those only we are going to discuss here. Okay, the chapter starts with an ostrich experiment. Okay, uh, it starts with this experiment. You don't need to by heart it, but you need to understand it. Okay, what ostrich observe is that suppose here is a wire, okay, and let's say in this wire the current is passing along this direction, say, okay. Why the current is flowing, we are not interested. Just say the current is going this way, up. Then what it has been found, a compass, okay, a magnetic compass. It, when the current was flowing, suppose the compass was showing this way, when the current was passed, the compass shows the deflection. Okay, all right, the compass shows the deflection. Okay, then when the current was off, the compass came back to its original place. Say the compass was previously pointing here, but when the current was passed, the compass shows the deflection. Okay, now if the direction of the current have been reversed, okay, then it have been found that the direction of deflection of the compass has also got reverse. Okay, so what does it shows? Why the compass shows the deflection? Okay, compass shows the deflection because of the magnetic field. Okay, then when the current carrying wire shows the deflection in the compass, means the presence of magnetic field. So what is the baseline here is current, okay, current carrying wire, okay, wire behave as magnet, This is the main thing that which was observed very first by the ostrich. Okay, current carrying wire behave as a magnet. Now if the current is behave as a magnet, then the magnet must have a magnetic field associated with it. Okay, then one or two things what you need to remember is we denote magnetic field, okay, by the symbol of B. So you need to familiar with this symbol. B stands for magnetic field, new concept. Okay, then magnetic field, just like electric field, it is a vector quantity. The unit of magnetic field in SI, unit of magnetic field in SI is Tesla. In honor of Nicholas Tesla, we named it as Tesla. Or you will also in Tesla is one of the unit in SI. Apart from that, it is Newton per ampere meter. This is another unit. Another unit there is, which is Weber per meter square. This is another unit. Okay, this Weber is completely new for you. Even Tesla is new for you, but you need to remember it that the unit of magnetic field is Tesla, either Newton per ampere meter per, or it is Weber per meter square. This is just the introduction. Okay, now what is Weber? I think you have heard about the electric flux. Similarly, just like the electric flux, what it was defined, electric flux is equal to E dot A, right? Similarly, the flux in magnetic field, we have it as B dot A. Okay, now the unit of flux in magnetic field is Weber. Okay, and this is equal to magnetic field. A is what? Meter square in SI. So what it is. Weber divided by meter square is equal to the unit of magnetic field. So it comes from here. Okay, so it has similarity with the electric flux. Okay, now how to find out the magnetic field due to a current carrying loop or a wire. Okay, this, to find the magnetic field by the current carrying wire, was first found, let me say, by Biot-Savart. Okay, Biot-Savart. This T is silent. Okay, so it's written, it is in Biot-Savart law. Okay, Biot-Savart, what they did, two people actually, they found the magnetic field due to a very small wire. Okay, I must say this is a small wire. Okay, small wire. Okay, say the current I have been flowing through it, let's say. Okay, this is a small wire. Again I'm saying, due to this elemental section, again in that, say this elemental section is dl, very small length, at r distance away. Okay, at, say this point is P, at the distance of r, say, okay, let theta be the angle between dl and r. Okay, Biot-Savart say the small magnetic field at this point P due to the current carrying small length dl is given by the small magnetic field due to dl at P at the distance r, making an angle theta. The direction of dl is along the direction of current. The direction of r is away at this point. Okay, this is given by some constant. This is a constant. Okay, its value is 10 to the power minus 7. This is a constant, just like electric field. This equal to I dl cross r divided by r cube. Okay, then this dB, it becomes what? Mu 0 4 pi I dl cross r by r cube. This law means Biot-Savart have given a means to find the magnetic field at any point due to a small elemental length, and this law is known as the Biot-Savart law. Okay, I have written everything in terms of vector. Okay, magnetic field is a vector quantity. Mu 0 by 4 pi is just a number, 10 to the power minus 7. Current is a scalar quantity, dl cross r. Okay, if I write the same thing in terms of magnitude, okay, if I just want to find out the magnitude of dB, then how I will write this equal to what? Mu 0 by 4 pi in terms of magnitude, dl and r. Cross product is what? Sin theta will come. dlr, what is the angle between dl and r? It's theta. We have taken it over here, right? R cube, right? Then r cube and r, one will cancel out, remain will be what? R square. So in the book you have written, you had seen this way also. However, it carries the same meaning. Okay, sin theta by this. This way we can find out the magnitude. Alright, this way we can find out the magnitude. However, the magnetic field in all total is this one. Okay, this is the magnitude only. Now what is the direction of dB? Okay, the direction of dB is across. The direction of dB is, it involves the cross product, right? Means the direction of dB is perpendicular to dl, perpendicular to r. Do you remember? We have learned something A cross B, right? Now what is the direction of A cross B? Direction of A cross B is perpendicular to A and perpendicular to B, right? Yes? Or else, how to find out the direction of A cross B? Perpendicular to A, perpendicular to B, right? Or we can also find out screw rule. Do you remember screw rule in cross product? Yes. You know screw, right? Isn't it? Right hand screw. Make the rotation from DL to R. Okay. If you make the rotation from DL to R, okay, what is the direction of DL? Along the direction of current. When you, at this point, okay, the direction of DL is across here, R is across here, you make the rotation. Okay. Now, in what direction the screw will go? Whether it will get tight or whether it get loose. In this case, you are making the rotation in the clock sets, DL to R. So what? It get inside, right? So what is the direction of magnetic field at this point P? The direction of magnetic field is inward. Okay, so this is coming from the screw rule also. Okay, so the direction of DB can be known from the screw rule. Okay, or okay, so what is the direction of DB across here? Do you know? This is screw. Means when the screw goes inside, inside, right? How will you see? You will see like this, right? So this is the way to show the direction. Okay, and if you make the rotation anti-clock, loose, right? How it will come out? What will you see? You'll see the top, just like an arrow. If the arrow goes inward, all right, how will you see this one? But if the arrow comes outward, how will you see coming towards you? All right, so this is one thing. From the screw rule, you can know the direction of DB. Apart from the screw rule, see, there are sometimes right hand, left hand, right hand, left hand. Don't get confused. There is another alternative method, that is right hand thumb rule. Right hand thumb rule. What you need to do? You need to have the right hand. Okay. Then the thumb, you point the thumb along the direction of the current. Then these fingers, where it point, that is the direction of magnetic field. Again I am saying, hold the thumb across the direction of the current, and where this forefinger will point, this is the direction of magnetic field. Now in what direction the current is? Going this way, right? Now what is the direction of magnetic field at this point? Inward. Going inward, right? So if it is inward, how are you going to show it? By means of this. Alright, so screw rule will also work, right hand thumb rule will also work, but still this always hold correct. I prefer the students to go with the screw rule rather with the right hand rule, but the right hand rule is important. Right hand, use your right hand. Again I'm saying, okay. So if it is so remember about the Biot-Savart law. By using the Biot-Savart law, we can find out the magnetic field due to a small elemental section. Okay, now if the current goes this way, suppose this is a wire. At this point, what is the direction of magnetic field? Thumb rule. What is the direction of magnetic field? Cross, right? At this point, what is the direction of magnetic field? Right hand thumb rule, right? Fine or not? All right. Now another. The current is going this way. All right. What is the direction of magnetic field at this point? Right? What it is? It's coming. What is the direction of magnetic field? This one. Right? Fine. Now down. What is the direction of magnetic field? Inside. Cross. All right. Now let's say another. Let's say this is current. Say this is current. All right. Say this is current means what? This dot and cross means inward, inside, dot means outside. Now this dot, what does it mean? These are the symbols just to show that in what direction it's going. Now this dot means what? The current is coming in what direction? Outward, right? Now what is the magnetic field at this point? At this point, let's say. Then what? Correct? What? What is the direction of current? The direction of current is like this. Correct? This is the direction of magnetic field. Right? Now, here, what is the direction of magnetic field? The direction of magnetic field is like this. Okay? So what I'm going to summarize it is that Biot-Savart law is the means by which we can find out the magnetic field due to the elemental section, due to a small section of wire r away, r distance away. The direction of the magnetic field is given by either the screw rule or either by the right hand thumb rule. Thank you.